Hello everyone. Today we are going to see the concept level shifter or level translator. In this video you are going to see why we have to use level translator or level shifter circuits in the internal circuit of op-amp, and what is level shifter, what are the circuits used to design the level shifter in the internal circuit of op-amp. Now we will see why we have to use the level translator in the internal block of op-amp. Okay, so if you observe, the first two stages of op-amp is nothing but the input stage and intermediate stage. These two stages are directly connected. We know from the basic definition, that is, if the two stages are cascaded, we have to use a coupling capacitors in between the two stages. Okay, so at the input stage, the output of the input stage must be passed through the coupling capacitor and must be given as input to the second stage. Why we have to use the coupling capacitor means, this we know that from the basic property of capacitor, it blocks the DC signal and it allows only the AC signal. If you are not using this coupling capacitor in between the two stages, then along with the amplified version of AC at the input stage, some part of DC will be transmitted through the intermediate stage. So, since the intermediate stage, some operating point will be there for the transistors. Because of additionally added DC signal with the incoming signal, the operating point of the transistor used in intermediate stage will changes. Means this will not be in active region, so the amplification will not be happen. So since the major drawback of not using a coupling capacitor is the DC signal is also added along with the AC signal. Okay, now what happens if the DC signal is present in the AC signal? These effects of DC component that are present in AC is the output signal gets distorted, and also it limits the maximum output voltage swing. Now we will see the waveform, how the signal will present at the output of an intermediate stage with using coupling capacitors and without using coupling capacitors. Okay, so if you observe, this is the output signal with 0 DC level. For the op-amp we are having some saturation levels, that is plus Vsat and minus Vsat, nothing but power supply levels, and here the DC level is of 0. That's why an amplified output without no information loss or with distortion free is obtained. Okay, if you observe in this waveform, since the input stage and intermediate stage is directly connected, and because of that some DC level will be present, so the signal is having both AC and some DC component, and because of this presence of DC, the output signal is shifted and it crosses the saturation level. Since it crosses the saturation level, the portion, if you observe the portion at this point, the portion at this point is distorted. Okay, so the portion at this point is distorted, means some information will be lost. So without, one way of not adding DC signal or blocking DC signal is with the use of coupling capacitors. Since the internal circuit we are not using capacitors, we have to use the other method, that is level shifter or level translator circuit. Now what is the main purpose of level shifter? So the main purpose of level shifter stage or level translator stage is to bring this DC level to the minimum potential, that is the minimum potential is 0 without change in AC signal. Okay, if you bring the DC level to the minimum potential, then we can clearly obtain this type of waveform at the output of level shifting stage without using coupling capacitor. So the main purpose of level shifting stage is to bring down the DC level to the ground potential with the minimum change in AC signal. Now we will see what are the circuits are involved in order to bring down the DC signal without change in AC signal. Circuits that are used in level shifting stage. Consider the first circuit. So in this, it is the basic model circuit that is used. Here the input signal is given at base terminal of transistor and the output is taken from the emitter terminal. So this circuit is nothing but a common collector configuration. So here it is also called as emitter follower circuit. Okay, so we know that this emitter follower circuit is nothing but the input signal is always equal to the output signal. So in this, the input signal containing both AC and DC is present at the input of the transistor base terminal. Here we have to obtain the output signal which consists of only the AC signal, and the DC signal should be eliminated. Means at the input the signal is having both AC and DC, but at the output the signal is having only AC but not DC. This is the main motto. For this, we have to mathematically prove how the DC level is reduced. Okay, so now we are performing the analysis. So here apply KVL to the base emitter loop. Okay, so apply KVL to this base emitter loop. We know that the Kirchhoff voltage law is nothing but the algebraic sum of voltages across the loop. So if you observe here, it is minus V in plus VBE plus here V0 is nothing but voltage drop across the resistor R, so which is equal to 0. Therefore V0 is V in difference VBE. Here the VBE is nothing but the cut-in voltage of the transistor Q1. For example, if you consider silicon, then the cut-in voltage is 0.7 volts. Okay, so if this input signal V in consists of both AC and DC signal, this DC value is subtracted from the cut-in voltage value. So we know that if V in is an increased DC level, then from this expression we can say that the obtained output V0 is nothing but a decreased DC level. But the major drawback of using this circuit is this circuit DC value is fixed, that is the cut-in voltage VBE. If you consider silicon, then it is 0.7 volts, or germanium, then it is 0.2 to 0.3 volts. Okay, in some cases this 0.7 volts is not enough to bring the DC level to 0. So up to the input signal having below cut-in voltage of silicon, then we can use this circuit. Okay, the circuit 1 is modified and named it as circuit 2. In this, if you observe the difference between circuit 1 and circuit 2, at the emitter terminal, the resistor R is divided into two equal halves or two unequal halves that are named as R1 and R2. So from this circuit, we have to find out what is the output voltage V0. Okay, and how the DC level in the output voltage can be reduced when compared to the DC level in the input voltage. So if you observe, the output voltage V0 is nothing but the voltage drop across the resistor R2. So from the Ohm's law, we can write the V0 as I into R2. Now what is the next step we have to find? We have to find the value of current I. Okay, so we have to find the value of current I. This current I can be found by applying KVL to the base emitter loop. Okay, so if you apply KVL to the base emitter loop, we can write the equation as minus VI plus VBE plus I into R1 plus I into R2. Okay, in this way you will write the equation by applying KVL to the base emitter loop. If you solve this equation, then we can write the current equation I as VI minus VBE by R1 plus R2. We know what is the output voltage expression. Simply substitute the value of current I in this output voltage expression. We will get the V0 as Vi minus Vbe by R1 plus R2 into R2. Okay, so in this way we will find out the output voltage V0. Now next see how the DC level is reduced. So from this equation, if you observe, if you maintain the proper values of the resistors R1 and R2, then the DC voltage in the output expression V0 can be reduced when compared to the DC level present in the Vi. So we can see that here a cut-in voltage Vb is there. Some DC level in the V0 value will be reduced, and if you properly maintaining the ratio, that is R2 by R1 plus R2, then the DC level in the output voltage will be reduced. And what is the drawback of using this circuit, or what are the drawbacks of using this circuit? The first drawback is the output impedance. Since we are using the emitter follower circuit, the output impedance of basic emitter follower circuit is less. But here, because of addition of resistors, the output impedance of this circuit is high. There may be chance that it cannot load the other circuits. And second disadvantage or second drawback is the signal voltage gets attenuated by the factor R2 by R1 plus R2. This indicates that the AC signal, means the output signal, is also gets reduced by the factor, that is R2 by R1 plus R2 from this V0 expression. So these are the two drawbacks of using this circuit too. Now we are going to see the another model of level shifter circuit, which uses a current mirror circuit to the basic emitter follower circuit. Here we are considering the basic emitter follower circuit is nothing but the use of circuit 1. So at the emitter terminal of circuit 1, the current mirror circuit is used. So if you observe, this is the current mirror circuit, and the above one is nothing but the emitter follower circuit. So this is our emitter follower circuit. To the emitter terminal of this circuit, a current mirror circuit is used. Okay, so from the basic definition of the current mirror circuit, we know that the currents at the output voltages are same. Means the current I1 and the current I2 are same. Okay, now from the current mirror circuit, or from the design of a current mirror circuit, we know what is the value of current I2. So I2 value is nothing but VE minus VBE by R2. So we have to perform some analysis at this point, and directly apply KVL to this loop. We can obtain the current I2 as VE minus VBE by R2. While doing this analysis, we have to assume that the gain of the transistors Q2 and Q3 is of high value, and these two transistors are matched transistors. Matched transistors in the sense the properties of these two transistors are of same, and the types of these two transistors are also same. Okay, now from this circuit, the next step what we have to find out, we have to find out what is the output voltage V0 and how the DC level can be reduced in the output voltage when compared to the DC level at the input voltage. Simply apply KVL to this base emitter loop of a transistor Q1. So if you apply KVL to this base emitter loop, that is minus Vi plus VBE plus I1 into R1 plus V0 equal to 0, means V0 is Vi minus VBE minus I1 into R1. So VBE is nothing but cutoff voltage of silicon transistor of type Q1, and here the I1 value we have found, that is equal to I2, which is a current value of current mirror circuit, and R1. So by properly choosing the values of resistor R1 and the current I1, the DC level in the output voltage can be reduced. Okay, these are the three basic circuits that can be used in level shifter block. So why we have to use a level shifter is, in brief, the intermediate stages and the input stage are directly connected. So because of the directly connection of the two stages, or I can say the cascaded of differential amplifier circuits without using a coupling capacitors, the DC level is added at every stage in the output signal. Because of addition of DC level at every stage in the output signal, the signal is clipped at the output. Due to this, we have to use a coupling capacitor. But what happens if a coupling capacitors are used? If a coupling capacitors are used, for every two stages we have to use a single capacitor, and the total circuit should be fabricated in the single IC, as we know that the integrated circuit is of small in size. So the capacitor at the in between the two stages is fabricated, and the fabrication of capacitor on an IC is too difficult. That's why to avoid the fabrication of capacitor in an IC which is difficult, we can use the level shifter circuit before the output stage of internal block in order to regain our AC signal and block the DC signal. So in this way, we can use the level shifter circuit. Thank you.